In the sweltering heart of the Negev Desert, Israel took a $3 billion leap to carve an artificial river through shifting sands, betting it all against a national water collapse. Why gamble on 70,000 tons of sand moved each day, risking an entire economy on pipelines and salt water? The answer rewrites everything you thought you understood about survival and exposes what was really at stake when the taps nearly ran dry. By the early 1950s, Israel's future was drying up fast. Underground aquifers, the country's last natural reserves, were falling at a rate that outpaced rainfall by millions of cubic meters each year. Wells in the Negev turned brackish, crops withered. Maps from the Ministry of Development showed a nation boxed in by its own geography, the Sea of Galilee in the north, the Mediterranean to the west, and a vast sun-baked desert stretching south. On cabinet tables, the numbers were stark. The national water carrier, first proposed in 1953, would cost 420 million Israeli lira, about $112 million in 1964. That was nearly 5% of the entire country's gross domestic product at the time, a figure that dwarfed most national projects outside the military. For comparison, the Aswan High Dam in Egypt would cost about $1 billion by 1970. Israel's gamble was not just about money, it was about survival. Every shekel spent was a wager against collapse, a bet that engineering could outpace drought. David Ben-Gurion, the country's first prime minister, pressed forward despite fierce debate, convinced that water was the only way to turn the Negev from a wasteland into a home for new arrivals and a backbone for agriculture. The decision locked Israel into a race against nature, forcing the government to commit resources, labor, and political capital on a scale the country had never seen. The national water carrier was not just a pipeline, it was a lifeline drawn across the sand with the hope that it could keep a nation alive. Under a sky that shimmered with heat, survey teams stepped into the Negev with little more than topographic maps and the relentless sun at their backs. Temperatures soared to 115 degrees Fahrenheit, hot enough to make steel tools sear the skin. Every step forward meant guessing what lay beneath the surface: hard rock, loose gravel, or pockets of sand ready to swallow heavy machinery. The route for the national water carrier could not afford mistakes. A single miscalculation risked years of work and millions of lira. Engineers from Tahal, Israel's national water planning agency, relied on ground-based surveys and aerial photography to chart a path through the desert's ever-shifting contours. Teams drilled boreholes deep into the earth, sometimes more than 100 feet down, pulling up samples to read the hidden language of the land. They camped for months, marking out the line with stakes and flags, inching forward with the precision of a surgeon. The desert was not a blank canvas. Wind corridors funneled sand across the route, threatening to bury equipment overnight. To counter this, field specialists recorded wind patterns, measured dune migration rates, and mapped low ridges that could offer natural protection. Bulldozers worked in tandem, flattening high spots and redistributing sand to build a stable corridor. Crews sprayed groundwater to keep the sand from blowing away, then sent in steel rollers that shook the earth with the rumble of heavy drums. Each section of ground had to be compacted until it could withstand the weight of concrete, pipes, and eventually water itself. The result was a corridor cut with scientific discipline and brute force, a path where discipline mattered as much as endurance. In the Negev, the difference between success and failure was measured not just in miles, but in the ability to read the desert's secrets before laying a single pipe. Excavators lined up along the corridor, engines roaring in the morning heat. Each day, crews removed up to 70,000 tons of sand and soil, carving a channel that would eventually stretch 250 miles through the Negev. The planned width, 150 feet across, demanded not just brute force, but careful choreography. Bulldozers and graders worked in sequence, shaping the ground to match a precise U profile. Surveyors paced the length with laser leveling instruments, checking the gradient every few hundred feet. The canal slope, just 1 inch for every 100 feet, had to be exact, or water would pool in dead spots or surge too quickly, eroding the banks. Logistics were relentless. Dump trucks cycled in and out, hauling away debris while fresh sand was brought in to fill low spots. Field engineers monitored every stage, recording elevation and compaction data in notebooks smudged with grit. The sun hammered the site, but the pace never faltered. Each pass of the heavy machinery brought the canal bed closer to its final geometry. By dusk, the rough sands had been transformed into a corridor defined by mathematical precision, ready for the barriers that would keep the desert's thirst at bay. A canal through the Negev's shifting sands faces a silent enemy, the ground itself, thirsty enough to swallow water before it ever reaches a single farm. To defeat seepage, engineers designed a multi-layered defense. The base starts with a 2-inch layer of fine sand, leveled and moistened until it forms a perfect bed. On top of this, crews roll out thick sheets of high-density polyethylene anchored deep with steel pins. Each seam is welded shut by a dedicated team, their torches moving in slow, deliberate lines. Every weld then faces a battery of vacuum tests, searching for the smallest flaw that could become a future leak. Above the membrane, workers lay down 5-inch thick concrete panels, each 16 feet long. Hot bitumen fills the joints, sealing every gap, and allowing the structure to flex as desert temperatures swing from freezing nights to blistering days. The canal's geotechnical lead inspects the work daily, checking tolerances, reviewing test logs, and signing off only when every section passes. The maintenance schedule stretches decades ahead, with routine checks for stress, settlement, and even the tiniest seep. This architecture turns the canal into a watertight artery, ready to deliver life across the desert's most unforgiving ground. Salt water from the Mediterranean enters the plant through massive intake pipes, moving first through a gauntlet of mechanical screens and sand filters. The goal is simple: strip out every grain of silt, every shell fragment, before water ever touches a membrane. An operator in a blue uniform checks the gauges as the water passes through layers of gravel and anthracite. Then a bank of cartridge filters fine-tunes the clarity. Pretreatment is relentless, because even a hint of algae or grit can foul the next stage and drive up costs. Now comes the heart of the process: reverse osmosis. High-pressure pumps force water against a wall of polymer membranes at up to 70 bar, or roughly 1,000 pounds per square inch. Here, salt and impurities are trapped on one side, while pure water passes through to the other. Energy recovery devices, spinning metal cylinders, capture the leftover pressure, recycling it to slash electricity use to about 3.5 kilowatt hours per cubic meter. The operator watches as the Permian water, purified to near laboratory standards, emerges almost too clean for human use. To restore taste and safety, precise doses of calcium and magnesium are added, bringing the water back to a balanced mineral profile. Each batch is tested for pH, hardness, and residual salts before it leaves the plant, ready to enter the network that supplies cities, farms, and schools miles away. Water from the Mediterranean, stripped of salt and balanced for taste, now surges through a network that reaches deep into the Negev. At the heart of this system, real-time telemetry tracks every liter. Digital dashboards and control rooms flash with updates as sensors in the fields report soil moisture and flow rates. The numbers are staggering. Israel's desalination plants deliver nearly 1 billion cubic meters each year, accounting for as much as 80% of the nation's domestic supply. On a farm near Yeruham, a Negev grower checks his phone for irrigation data. With drip lines running beneath the dust, he uses 60 to 70% less water than his father used. Each drop is measured, each vine accounted for. The crops thrive where once there was only sand. An environmental official reviews salinity reports and satellite images, watching for signs of stress in the fragile desert ecology. The system's reach is broad, but not without cost. Energy use climbs, and brine disposal remains under scrutiny. Still, as the first test flows fill the pipes and water bursts from new spigots in dusty villages, the gamble pays off, at least for now. The desert drinks, and the country's future, for a moment, feels secure. Today, nearly 80% of Israel's tap water flows from desalinated Mediterranean seawater. That technology is now exported to drought-stricken regions worldwide. As water stress accelerates globally, the Negev stands as proof. Survival in the age of scarcity demands engineering, relentless adaptation, and the courage to bet on the impossible. What would you risk?